Good morning, guys. In our earlier video, we discussed that the part of metal with the chapter of 10th non-metal and metal, third chapter. We discussed that the part of metal side and their chemical behavior, their properties in the previous video. I hope you guys like this video, like that video, and also you will understand the topic with so many examples, and with this you can understand the topic in brief and with important examples, and it all considered from the NCRT and NCRT base, so you can conclude your theory and conceptual base with this video. Hope you guys enjoy the session. In our last video we discussed that about metal behavior. In this video we will only talk about non-metal. What we understand by non-metal. Firstly the example of non-metal and the definition of non-metal we will discuss. Examples are like carbon, sulfur, iodine, bromine, hydrogen. They are the example of non-metal. By the non-metal word, what we can conclude this from: in non-metal, the electronegative elements are called non-metal. Non-metals are generally acidic in nature because of gaining electrons. I repeat, in electronegative elements and because of gaining electrons, this behavior it's called non-metal. In also another ways, we can say the non-metals are acidic in nature and produce oxides. In the brief definition of non-metal, we can say the non-metals are oxidized, and the non-metals are acidic in nature and oxide produce. Okay, we take an example of this. From the example of chlorine we can understood it better. The in chlorine 17 in chlorine 17 atom, uh, 17 with a number of molecular, yes, 2, 8 and 7. From it, if it make a chlorine ion, then it gave and then it take a uh, free electron and it became 288. From a outermost shell it to take an electron and became chlorine ion, and it is a negative ion. Okay, move to the properties and the another things of non-metal, the behavior with different uh, properties, and the behavior with different chemical and reactions with them. Firstly we will talk about reactivity with oxygen. As I earlier told you, then with the reactivity of oxygen, non-metal produce oxides only. With the reactivity of oxygen, it produce oxides only, and gives a hydrogen gas. It also the behave acidic and neutral also. For example, with the non-metal reactivity with non-metal and with the oxygen, it gives non-metallic oxides, and its behavior will be acidic or neutral also. Next, with the carbon combined with oxygen gives carbon monoxide. It is also neutral in nature, and the same with the carbon with oxygen in the reactant gives carbon monoxide as a product, and it is also acidic in nature. So that we can say the non-metals are acidic and neutral as well as. Next we move to the next part of this non-metal, reaction with water. Reactivity with oxygen we have seen. In the next part, the reaction of non-metal with water. You are very happy to say this, that the non-matter do not react with water, so that you don't have to learn this property and this kind of behavior of this. You are totally free from this. And again we will discuss the non-metal reaction with dilute acid. It also do not react with and do not displace hydrogen from acids. Okay, in the non-metal it do not displace hydrogen from acid. Next we see the reaction with salt solution. A non-metal reaction with salt solution, non-reactive, more reactive non-metal displays a less reactive non-metal. As I earlier seen the in the behavior of metal, the more reactive metal displays the less reactive metal. In the same thing, the non-metal in the salt solution, from the salt solution, more reactive non-metal displays the less reactive non-metal. Take an example and understand it better. For example, we have a sodium bromide and react with pass through the chlorine gas. It gives 2 NaCl, sodium chloride in the aqueous form, and bromine in aqueous form as well as. In the reaction of non-metal with salt solution, we see the more reactive non-metal displays a less reactive non-metal. Oh, okay. As very similar in the metal case, the metal are more reactive metal displays the less reactive metal. For example, we have taken an example of zinc and copper. Zinc is more reactive than copper, and copper displays, and zinc became combined with the another metal. Okay, next move back to the non-metal behavior. 2NaBr, we take this example. In the same thing, that sodium bromide taken an aqueous form and chlorine gas pass through, it gives 2 NaCl, sodium chloride, and sodium chloride is a ionic compound, and also it behaves solid in nature, and harder in the property of. In this example, the chlorine is more reactive than bromine. That's why the chlorine may combine with sodium and give bromine, displace bromine. Next, we'll see how the metal and non-metal react. How do metal and non-metal react? As I've earlier told you, that the sodium and chlorine combine with each other and make a bond of ionic and make a bond that is called ionic bond. In the ionic bond, the negative and positively charged particle make combine of the compound and make a combination, or we can say make an ionic bond with this. The sodium with free charge particle, sodium atom 281 it have, and with the chlorine atom it may have 287. Okay, the sodium have free electron, it gives to the free electron to the chlorine atom, and it make sodium ion. So if it give a sodium, it give a free electron to them, then the sodium became sodium ion, so we can say this the cation, and sodium atom 28 became 28 in the atom form. And with the what happened with the chlorine may have get a electron, it take an electron and became chlorine ion 288. With the negatively charged particle it became an anion, or we can say that the product, as we can say, sodium chloride it became. how do metal and non-metal react? In this case, we have understand with this example of very easy. You have understood that the sodium, again we'll repeat, the sodium atom 28 with the free electron of 281, with its have a free electron in its outermost shell. Sodium gives one electron to the chlorine because it need one electron, so it can make its outermost shell complete with its octet 288. So chlorine get an electron and make a chlorine ion with 288 and became an anion with the negative charge particle with the chlorine. And sodium, it gives an one electron, so it have only 28 electron its out in its outermost shell and became a sodium with positively charged particle. With positively charged particle, it is called as a cation. Okay, with this it gives sodium chloride. Sodium chloride is a harder in property and solid in nature. So we can say that sodium chloride became, as we have seen, that in the NaNCl, it became the NaCl sodium chloride with the bond of ionic bond. So we take properties of ionic compounds. In the properties of ionic compound, we will discuss four of its properties like physical nature, melting and boiling point, and solubility, conduction of electricity. And after that we will discuss the occurrence of matter. That's how we deal the uh, non-metals of the properties of. Okay, non-metal properties of ionic compound. Firstly, we will talk physical nature. Physical nature, the first property of the non-metals. Physical nature, as I've earlier told you that in the non-metal they are solid in nature and harder in the outer surface due to strong electrostatic force of attraction. Because in the non-metal they have strong electrostatic force of attraction, that's why in the physical nature they are harder and solid in nature. They are solid in nature and harder in outer surface due to strong electrostatic force of attraction. Because it seems very electrostatic force and with the help of ion, because it have the free electron, or we can say free charged particles, they have make electrostatic force, and in the uh, solid they have a little space to movement, to move one place to another. They became an strongly electrostatic force of attraction. Move to the property of ionic compound, like melting point and boiling point. In non-metal, they have strong interionic attraction present in between the ions of opposite charge. Because in the non-metal they have became combined with the opposite ion, like sodium and chlorine. Sodium with positively charged particle and chlorine with negatively charged particle, they became combined and make a compound of sodium chloride. With melting point and boiling point of non-metals and ionic compounds, they have strong interionic attraction are present between the ions of opposite charged particles. Thus to break ionic compounds need more energy, so that's why the boiling points are high. In non-metals, generally we see the metals have highly boiling point, but also in non-metals they have ionic compound, melting and boiling points are very high. In the same, generally we see the example of wait took an example of like cesium and another one like gallium. They are very they are very low melting point, because on the palm it also molten. Okay, move to the solubility. Non-metal or ionic compounds, they are soluble in water, because water is a polar solvent, and it is very comfortable with water. They easily soluble in water. Water is a polar solvent, but in the insoluble but they are also insoluble in non-polar solvent. In non-polar solvent like petrol, kerosene, they are insoluble. They shows the insoluble behavior. Insoluble in so thus we can say insoluble in carbon tetrachloride like benzene, ether, alcohol, and and another with this petrol and kerosene as we can take. They are non-polar insolvent. Move to the next property of ionic compound: conduction of electricity. Because you all have known that the conduction of electricity and conduction of electricity is due to movement of charged particle of electrons, movement from one place to another. They they lose or gain electron, then the electricity may get produced. So we can say conduction of electricity in non-metal or in ionic compound due to movement of charged particle. In ionic compound exhibits electrical conductance due to movement of ion like molten or in aqueous state, because they are in solid state, and they do not have intermolecular or space, interionic space. So they do not show the electricity, but in the form but it in the form of aqueous solution, or with combined with water, it exhibits electrical conductance due to movement of ions. The ions may get moved from one place to another, and they make an exchange or share electrons and electrons so that the conduction of electricity may produce. Next, we will discuss the very hard part of metals, and it called occurrence. Some students say think that the it is very difficult, but it is not. Occurrence of metal. Occurrence of metal. It all in occurrence of metal in our earth crust or in the ore, it found in the either in the free state or in the form of compound. In our earth crust, either it found in the free state in our nature, or in the minerals in the very form amount of this, or in the form of their compound. In the crust of earth, it have two states: first native state of free state, and the another is combined state. In the native state of earth crust, they are very uh, less reactive, or we can say very unreactive or inert, because they all are like bottom in the reactivity series, like silver, copper, gold, and platinum. The native state of free state are very unreactive in non-metal, because which lie at the bottom of reactivity series, and they are chemically inert. For example, silver, copper, Au gold, and platinum. They do not react at any case. Okay, next move to the combined state. In combined state, they also have in compound and with the state of free as well as combine. In combined state, the examples of sodium and magnesium they found in compound, and in the free state as well as combined, copper and silver. I hope guys you enjoy the session. I try to convince or uh, brief as well as I can say with the conceptual base. I hope guys you like this video, and it is very helpful for your understanding the chapter 10 metal and non-metal. In our next video we will discuss the gang and the ores of the metal and non-metal. Thank you.